Okay, so PC17. So, yeah, these two calculations are very similar. I'll do the cross product one because that's the one that you specifically asked about, and it's just a certain amount of tedium, I'm afraid. So specifically, we're looking at the cross product of x and y. So x is going to be a function where we have x1 as a function of t, and x2 as a function of t, and x3 as a function of t. And I'm just going to write, just for convenience, I'm going to call that x1, x2, x3, and just remember that these are functions of t. Right? And then likewise, y is y1, y2, y3, and those are all functions of t. Okay.
Only in the R3, right?
Yeah, this only makes sense in R3 because cross product only makes sense in R3. That's right. So what I'm going to do is I'm going to compute both sides of this equation and just direct computation show that I get the same thing on both sides. So specifically then, first of all, let's compute what is x cross y. Well, yikes. Okay, so it's x1, x2, x3 cross y1, y2, y3, and that's, well, let's see here. It's x2, y3 minus x3, y2, and then x3, y1 minus x1, y3. Finally, x1, y2 minus x2, y1. Okay, there's the cross product. Now I need to compute x cross y prime. So I need to take a derivative of all of this stuff. And note that within this expression there are 6 individual little single variable products. And of course I know a single variable product rule. Right? So let's rewrite, or let's write this down. So derivatives here. Okay, first let's do the derivative of x2, y3. Well, that's x2 prime y3 plus x2 y3 prime. Now, let's take the derivative, don't forget the minus sign. Let's take the derivative of x3 y2. Well, that is x3 prime y2 plus x3 y2 prime. And then etc. So I've got to do this derivative and then all of these one at a time. Right? So I'll let you sort of fill in those blanks. Is that all right? Okay. Now, I could do two different things here. One thing I could do is I could then look at the right side of the equation, x prime cross y and then x cross y prime. Let me just take what I've got here and I'm going to rewrite it and turn this into that right side of the equation. And I think that's going to actually work out okay. Because what you sort of notice is there's a pattern here that if I look at those terms, and then if I also look at sort of group those together, I claim this is going to simplify pretty nicely. So let's look at the first, these things here. What have I got there? Well, I've got x2 prime y3 minus x3 prime y2. And the next one is going to be x3 prime y1 minus x1 prime y3. And then the next one sort of down here is going to be x1 prime y2 minus x2 prime y1, which you'll notice is exactly x prime cross y. Now, on the other hand, if you take these terms here, you've got, let's take them one at a time, you've got x2 y3 prime, and then you've got minus x3 y2 prime. And then etc., and I claim that this is exactly x cross y prime. So, oops. Yeah. So when you take this, write it all out, term by term, you get multiple terms for each term up here because of the single variable product rule on each of these. These multiple terms, in some sense, the first one, all of the first ones go into this. Where all the ones where you're taking the derivatives of the x component turn into this. And all of the second ones where you're taking the derivatives of the y components, those all turn into that. So you get this product rule for cross products. Does that make sense?
Yeah.
Okay. Is everybody happy with that? Okay. Right. And then let me just say it's very similar for the first one, for the dot products. It's a very similar thing. It's just less algebra.